This is the system we've been analyzing. Now, we have a situation where we know that this line has a capacity of only 10 spaces or 10 clients waiting in line at the same time. And we have a question that it's, do I need just one server to optimize this system? First of all, I'm going to go to the software, to GPSS, and let's see what we need to change. First, in the last program we saw, we had parallel servers. So we had a storage of a capacity of 2. I'm going to change it to 1 just to see if with the capacity of the line we can have just one server. Then we add a line being a storage with a capacity of 10. Then we generate the transactions every 5 minutes with a standard deviation of 1. Then we enter the line. Now the line is on storage, so we use the enter command. And we occupy one of the 10 spaces of the line. Then I add a queue with a different name. This queue is going to be inside of the storage, and the main reason for this is that we need to measure not only the waiting time in line, but the longitude of the line. In order to do so, we need to use the queue command, not because it's going to be an infinite line, but because we need to measure this waiting time and this longitude. The capacity is given by this enter, or better said, this storage, which we use by this with this enter. So we enter the line, we occupied one of the 10 spaces in the line, then we use the queue command and use a different name of line, and it says that we start measuring the time waiting in line. Then we enter the server because the server is a storage. Then we depart the line to stop measuring the time. We leave the line, the real queue, the queue with a capacity, the line with a capacity. We leave the space taken before. Then we get the service with an average of 10 and a standard deviation of 0.75, and then we leave the server. Finally, we exit the process and terminate. Now we're going to create a simulation. We are going to start it for 100 clients. We say OK. Then we look at the waiting time at the line that we created. We have an average time of 39.93 minutes. So we do need more servers. We need more than one server. So we return to the program. By closing these two windows. Then I increase the storage capacity of the servers, not of the line, of the servers. Then we create the simulation again. We start for 100 clients to finish the process. And we can see that with 2 servers, the clients don't wait any time in line. So this is how we can solve this situation in the system that we've been analyzing. What we did was to add a queue inside of a storage with a capacity. The storage has a capacity of 10, and we add a queue to measure time and longitude. That measuring told us if we needed more than one server attending the line. And we are going to finish this video